If you think making AI smarter just means creating a bigger model, then sorry, you're about to get a huge surprise. A tiny startup in Singapore just launched a new AI model, HRM, which I believe could be a real leap forward in AI's reasoning abilities. What's special about it is that it doesn't need billions of parameters. It doesn't need to consume the entire internet, and I'll explain why this might be the new direction for the entire AI industry. What is HRM? Its origin and the special reason. First, to understand why HRM is causing a stir in the AI community, we need to know where it came from and who is behind it. HRM is a product of Sapien, a startup based in Singapore. This company was founded not long ago, but it immediately grabbed attention due to its founding team and core engineers, all veterans from AI giants. DeepMind, the birthplace of AlphaGo, AlphaFold, Anthropic, the creator of Claude, DeepSeek, famous for optimizing high-speed AI models. XAI, Elon Musk's AI team. In other words, Sapien is like an elite squad that gathers people who are at the forefront of the global AI race, but now they're taking a different path. The special reason, against the bigger is better AI trend. The current AI market is obsessed with one belief: the more parameters, the smarter the AI. OpenAI, Google, and Anthropic are all jumping into the race to scale up models to tens or even hundreds of billions of parameters. But Sapien is taking the opposite direction. They're not trying to create massive models. They're focusing on simulating how the human brain thinks and makes decisions. They believe that effective thinking is more important than computational muscle. I see this as a very bold move. But if we look at technology history, many big breakthroughs came from those who dared to go against the crowd. Just like when smartphones came out, they didn't just make phones stronger. They changed how we use devices. And HRM is the same. It doesn't want to compete directly with GPT-4 or Claude by size, but wants to change the rules of the game. Okay, let me explain part 2 in detail. Human brain architecture in AI. Why it's different, so you can use it right in the video, with rich information, easy to visualize, with examples and personal perspective to help viewers understand how special HRM really is. Human brain architecture in AI. Why it's different. Most AIs today, including ChatGPT or Claude, think in a linear way, like writing an essay without ever going back to edit. But HRM? It thinks much more like a human. 2 brains in 1 model. HRM is designed with 2 main components. You can imagine them like 2 separate brains, but working in perfect harmony. High-level planner, the strategic brain. This part thinks slowly and deeply. Its job is to determine the big picture of the problem, analyze what kind of problem it is, and figure out the strategy. It's like a chess grandmaster looking at the board and planning 5-10 moves ahead. Low-level worker, the action brain. This part processes things quickly and in detail. Its job is to take commands from the planner and execute specific steps. It's like the assistant moving the chess pieces as directed, reporting the results immediately. The loop reasoning mechanism. The key isn't just the separation of the 2 brains, but how they communicate continuously. The planner sets the initial strategy. The worker executes and reports back. The planner evaluates, adjusts the strategy. Repeat until the optimal answer is found. This is something the transformer models can't do. Current LLMs generate answers in a linear sequence without going back to check or correct mistakes along the way. HRM, however, has the ability to respond and tweak its thinking process in real time. Example, solving Sudoku traditional LLM. It reasons in a chain of thought. If it makes a mistake at any step, the entire result is broken. HRM. The planner analyzes the structure of the Sudoku puzzle, identifies potential areas to solve first. The worker tries a number, checks the logic. If a contradiction is found, the planner adjusts the approach immediately, rather than continuing with the mistake. Result, HRM solves 55% of difficult Sudoku puzzles, while GPT or Claude churn 0%. Why this mechanism is important. It allows for flexible thinking time. Easy puzzles, a few loops. Harder puzzles, more loops. Self-checking along the way reduces the risk of errors propagating. It's similar to how the human brain solves problems. we often try, check, and adjust the plan. When I read about this architecture, it made so much sense that I thought, why hasn't this been done before? Current LLMs are like race cars. They run super fast but never check if they're on the right track. HRM is like a mountain climber, slower, but stops at each stage to check, ensuring a steady, secure climb to the top. And it's this caution that helps it surpass even competitors that are 4 times its size. Numbers, the reason that shocked me. Normally, when a tiny startup claims their model beats GPT or Claude, I'm usually half believing, half skeptical. But when I saw these numbers, I had to say, no way. ARC-AGI benchmark, the intelligence measure. ARC-AGI, Abstraction and Reasoning Corpus, Artificial General Intelligence, is a test considered by the AI community to be the IQ test for artificial intelligence. It doesn't just test knowledge, but requires the AI to reason and find new patterns. The results: HRM, 40.3%, Claude 3.7, 21.2%, OpenAI O3 Mini High, 34.5%. That means HRM doubled Claude's score and even surpassed an optimized reasoning model from OpenAI. This isn't a few percentage points difference for PR. This is a gap that changes the ranking order. And remember, HRM only has 27 million parameters. Extremely difficult Sudoku, the challenge that kills most AIs. Difficult and extremely difficult Sudoku puzzles are a nightmare for LLMs. If there's no checking and correcting along the way, the entire solution is wrong. The results: HRM solved 55% successfully. GPT and Claude, 0%, couldn't solve even one puzzle. This is the first time I've seen a small reasoning model completely dominate a sophisticated logic puzzle like this. It's like a student who studies for just 2 days, outperforming a professor who's been preparing for a year. 30x630 maze, spatial navigation test. A 30x30 maze is a test of the ability to find the optimal path, not just reaching the goal, but choosing the shortest route. The results: HRM found the optimal path 74.5% of the time. GPT and Claude, 0%. If AI were a driver, GPT would know how to reach the destination but might take a detour through 5 provinces. HRM, on the other hand, looks at the map, considers every turn, and chooses the quickest route. Key point: fewer resources, more results parameters, only 27 million, while GPT-1 had 117 million and GPT-4 has hundreds of billions. Training: only 1,000 examples per task. Time: trained Sudoku Pro level in 2 hours of GPU. Doesn't need huge datasets. Doesn't need pre-training for months. Practical impact: easy to run on a personal laptop. Can be deployed on robots, IoT devices, industrial machinery. Extremely low training cost, easy to scale. When I look at these numbers, I realize HRM is doing something that large LLMs can't, solving tough problems with strategic thinking instead of computational power. It's like a chess player defeating a huge brute force chess-playing robot with just a few smart moves. The reason for effectiveness: small but mighty. The benchmark numbers from earlier are definitely impressive, but if we stop there, it's not enough. The most important question is, why is such a tiny model outperforming the big giants? And here's the answer. It's not about computational power, it's about smart strategy. Large LLMs, GPT, Claude, rely on chain of thought, thinking step by step, writing each step down, and hoping the chain doesn't break. The problem: one wrong link, and the entire result falls apart. HRM skips this and replaces it with loop reasoning. There is always internal feedback between the planner and worker. Each loop is a check and fix done immediately. GPT is like a novelist who doesn't read back until they've written 300 pages. HRM is like a journalist writing each paragraph, reading it back, and editing immediately if it doesn't sound right. Adapting to difficulty. Current transformers always think a fixed number of steps: easy tasks, waste time and tokens. Hard tasks, insufficient thought, easy to make mistakes. HRM adjusts the number of loops. Easy tasks, only 2 to 3 loops, faster. Hard tasks, 10, 20 loops, more thorough. This is like a driver. Straight road, go fast. Curvy mountain road, slow down, observe closely. Optimized training, less data, more value. Just 1,000 examples to train each task reduces the cost of huge datasets. Training pro-level Sudoku in 2 hours of GPU. This opens up the possibility. A small group or individual can train their own models. No longer dependent on big tech's huge servers. Personally, I think this is a really important point. AI will no longer be the exclusive privilege of corporations. Local gradient update, the secret to saving resources. Large LLMs use deep backpropagation through time. They need to remember and synchronize numerous derivatives through many layers and over time, consuming a lot of RAM and GPU. HRM uses local gradient update. Updates are done piece by piece without needing to remember everything. Lighter, faster, and closer to how the human brain learns. Results: can run on a laptop or edge device. Potential for integration into robots, self-driving cars, drones, portable medical devices. Combining speed and control. Worker processes quickly, doesn't slow down the model. Planner controls, doesn't let the model go off track. This combination creates an effect similar to an F1 racing team. Driver, worker, speed. Technical team, planner. Pit stop strategy, tire adjustments, fuel optimization. What impresses me most about HRM is that it answers the question, how do we make AI stronger? Big tech chooses the answer, make it bigger. Sapien chooses the answer, make it smarter. And looking at the results, maybe the second approach is the way to truly make AI artificial intelligence. Why HRM is better than Transformer. If you want to understand why HRM is a game changer in the AI industry, we need to compare it to the foundation of most AIs today, Transformer. And this is when it becomes clear, they are not just different, they are almost playing in two entirely different leagues. Transformer, linear, one-way thinking. Transformer is the underlying architecture of GPT, Claude, and Gemini. How it works. Receive input. Think in a fixed number of steps for each token. Output token. Lock it in. No edits allowed. The consequences. Easy tasks. Overcomplicated steps. Wasting resources. Hard tasks. Not enough thinking. Easy to make mistakes. Cannot go back and correct errors midway. It's like taking a test with a pen. Once you've written something down, if it's wrong, you're stuck with it. HRM. Flexible thinking with feedback. HRM doesn't think linearly, it thinks in loops, loop reasoning. Each loop, a check and adjustment. The big difference, no fixed number of steps. Depending on difficulty, it adjusts how much it thinks. Can go back and adjust strategy midway. Planner and worker continuously exchange, like the coach and player strategizing during a game. Like playing chess, each move can stop, observe the opponent's response, and then change tactics. The ability to think longer. When needed, current transformers don't have a think longer button for hard problems. HRM, easy tasks, 2-3 loops, done quickly. Hard tasks, 15-20 loops, find the answer confidently. Real-world significance. For tasks requiring complex computation, HRM doesn't freeze or randomly guess. It significantly increases accuracy in fields like healthcare, science, and planning. Optimized resource usage and capability to run on small devices. Transformers need powerful GPUs and lots of RAM to maintain the entire neural network and backpropagation through multiple layers. HRM uses local gradient update, reduces memory requirements, can run on laptops, phones, IoT devices, applications, home robots, drones, self-driving cars, operating independently without continuously sending data to servers. This is where HRM poses a significant threat to big tech. It breaks the barrier that AI can only run on supercomputers. Scalability. When transformers scale up to billions of parameters, training costs and time increase dramatically. HRM. Few parameters but still powerful, easy to replicate. Add new capabilities, new tasks, quickly without affecting the entire system. Potential. Easily train personalized AI for individuals or companies. I'm not saying transformers are outdated. They're still incredibly powerful for language and content creation. But in the reasoning game, HRM is like a smart player who knows how to read the situation. while transformer is a machine that plays by a fixed script. And in the real world, the ability to adapt on the fly always wins. Applications, now and in the near future. What excites me most about HRM isn't just its intelligence, but how it excels in very practical applications. This is not an AI model just for bragging rights on benchmarks. It's already out in the real world. Current applications. Where is HRM now? Healthcare, diagnosing rare diseases. Sapien is experimenting with HRM as a medical assistant, helping doctors analyze symptoms and combine test data to identify rare causes that humans might easily overlook. HRM's strength here is multi-layered reasoning. It doesn't just match data, it checks the logic multiple times before making a diagnosis. For example, a case where 3 different doctors misdiagnosed, HRM identifies the true cause as a rare genetic disorder. Seasonal climate forecasting. HRM has been applied in seasonal climate forecasting, a very difficult problem due to limited data and frequent abnormal fluctuations. Results: 97% accuracy in predicting next season's temperature and rainfall. Why it succeeded. HRM can plan and analyze each data layer, then fine-tune the forecast based on internal feedback. Running on small devices. Because it only has 27 million parameters, HRM can run directly on laptops or even edge devices like smart agricultural machines or industrial devices. Potential future applications, near future. Home robots and personal care. With its flexible reasoning capabilities, HRM can become the brain for assistant robots, planning household chores and adapting to unexpected situations. For example, when you ask the robot to prepare breakfast, it not only grabs the right ingredients, but also calculates the shortest path in the kitchen, avoids collisions, and adjusts if it runs out of eggs. Self-driving cars and drones. Self-driving cars often struggle when the environment changes quickly. Blocked roads, bad weather. HRM can instantly recalibrate the optimal route when conditions change, rather than following a fixed script like many systems today. Personalized AI on laptops or phones. Because it doesn't need a massive server, each person can run their own version of HRM trained for their personal work or interests. For example, a medical researcher could train HRM specialized in analyzing patient gene data, all running locally without uploading sensitive data to the cloud. Combining HRM with LLM to create hybrid AI. HRM excels in reasoning, LLM excels in language. Combining them will create AI that is good at both talking and thinking. This could be the closest step to achieving true AGI. Why this is a huge competitive advantage. Big tech companies are focusing AI in the cloud and on servers, dependent on the internet, consuming enormous energy. HRM opens the door to decentralized AI. AI can live right on personal devices, working offline, with more data security. This not only reduces costs, but also changes how AI appears in our lives. No need for cloud account registrations. No worries about losing personal data. No interruptions when the network goes down. I believe HRM will not stop at benchmarks or lab tests. With its small architecture, intelligence, and ease of training, it has the potential to become the brain of all kinds of devices, from a drone in the field to a car in your garage. And if that happens, AI will no longer be something that lives only in data centers. It will be right in your pocket. Comparing with other new approaches, HRM is not the only effort to break AI's limits. Many groups out there are trying entirely new approaches. But if we put them side by side, I see HRM as already having one foot outside the lab. Continuous thought machines, continuous reasoning by Sakana AI. Idea, not stopping after a single reasoning step. The model continues to reason in the background, even after it is answered. Strengths, continuously updates and improves its answers. Weaknesses, still consumes resources constantly, not optimized for small devices, not proven to outperform in reasoning benchmarks. Compared to HRM, HRM also has a looping mechanism but stops proactively when enough is done. More resource efficient. HRM has benchmark data that dominates, while continuous thought is still in the demo stage. 1-bit LLM, extreme compression idea. Uses weights of only 1 bit to reduce model size, runs faster, consumes less memory. Strengths: very lightweight, easy to deploy on edge devices. Weaknesses: cuts too much information, lowers accuracy, especially in complex reasoning. Compared to HRM is lightweight while still maintaining high reasoning capabilities, balancing performance and intelligence. 1-bit LLM is like cutting muscle to lose weight, while HRM is like training to be both light and strong. Diffusion-based reasoning. AI-based image reasoning by Google Idea applies diffusion architecture used in AI-generated images like Stable Diffusion to reasoning. The model refines its answer through multiple noisy steps. Strengths: can adjust answers across many stages, similar to how a painting goes from blurry to clear. Weaknesses: very new. No clear real-world application beyond small benchmarks. Time-consuming reasoning process. Compared to HRM is faster and has already proven itself across many different types of tasks. Sudoku, maze, ARC-AGI. Diffusion reasoning is like an artist carefully painting, while HRM is like an athlete quickly calculating to make decisions. Why HRM is ahead has clear benchmarks, surpasses GPT and Claude in difficult reasoning tasks, has real-world applications, healthcare, climate, no longer just on paper, low cost, easy deployment, can run on common devices, balanced design thinking, not chasing extremes like bigger is better or smaller is lighter, but focusing on optimizing thinking. Looking at the bigger picture, I see many new AI ideas as being at the starting line, while HRM has already completed a few laps and crossed the finish line in some races. And what excites me is that HRM doesn't just prove its feasibility in benchmarks, but also shows how AI can think for itself without needing massive data repositories. Limitations and open questions. By now, HRM seems like a superhero in the AI world, but I've always believed no technology is 100% perfect. HRM also has weaknesses, and here are the things we need to keep in mind. Not strong in natural language and content creation. HRM is designed with a focus on reasoning, logic, not optimized for writing smooth essays, creating stories, poetry, or music, responding to long, emotional conversations. Compared to GPT-4, GPT-4 still excels when it comes to natural conversations or creative writing. Implication: if you need an AI to be a full office assistant, HRM can't replace LLMs just yet. Limited task scope. While HRM excels in Sudoku, maze, and ARC-AGI, it doesn't have widespread evidence in complex visual recognition tasks, combining multiple types of data, text, images, sounds. Example, a planning task that involves both map images and descriptive text. It's unclear if HRM handles this well. Unknowns. When scaling up, currently, HRM only has 27 million parameters. If it were scaled up to hundreds of millions or billions of parameters, will the loop reasoning architecture still maintain its efficiency, or will it face computational bottlenecks? This is a question only time and experimentation can answer. Technology competition. Big tech companies could easily adopt this architecture and integrate it into their LLMs. If GPT-5 or Claude 4 applies loop reasoning plus massive data power, would HRM still have an advantage? This raises the question of whether HRM can keep its lead in the future. Needs a strong community for development. HRM is open source. This is an advantage, but also a challenge. Needs the community's contributions to improve rapidly. If not, development could be slower than commercialized products. What if HRM is combined with a strong LLM like GPT-4? Would we be getting closer to true AGI if HRM was combined with a powerful language model like GPT-4? Do you want a strong reasoning AI that can't write poetry, or a great conversationalist AI that lacks strong reasoning capabilities? Would big tech copy this architecture and make it a mainstream trend? I think HRM right now is like an emerging chess player, playing exceptionally well in some tournaments, but still needing to prove itself in many others. And this is also what I like. It opens up a whole range of exciting questions for the future of AI, rather than just being a packaged technology. We've just gone from a small startup in Singapore to an AI architecture that could make the whole industry take notice. And personally, after reflecting on all that HRM has achieved, I have a few things to share. HRM is not the killer of GPT. At least, not yet. GPT, Claude, and Gemini still dominate in the fields of language, creativity, and natural conversations. HRM, on the other hand, is the reasoning monster. Strategic thinking, planning, solving logic problems. These are two different worlds, and I believe the future will be about combining the two, not one eliminating the other. What HRM proves: big doesn't always mean smarter. For years, the AI industry has been chasing the bigger is better mindset. More parameters, more data, more power. HRM proves that the architecture and strategy for processing information are the key to breaking limits. It's like in sports. A small but smart athlete can still beat an opponent twice their size. Why I like this approach: democratizing AI. No need for supercomputers to run it, opening up opportunities for individuals and small startups. Diverse applications can be embedded in robots, vehicles, medical devices, agriculture, and industrial equipment. AGI potential. This flexible reasoning architecture is very close to how the human brain works. But I am also cautious. It's still unclear how HRM will perform when scaled to larger levels. Competition from big tech could come quickly. Still doesn't fully tackle multimodal tasks, language plus images plus sounds at the same time. For me, HRM is like a glimmer of light in the dense AI forest. Small, but with a new direction. And if this light continues to shine brighter, it could lead us to an AI era that not only talks but truly thinks.